Okay, so before talking about the Hadoop, we need to learn some basics about big data. From what sources it is getting generated, what kinds of the data that you have to deal with on this framework. Okay, so what is big data? What is the definition of the big data? Okay, so for example, your Java technology or the database servers that you have, all these technologies, say either .NET framework or Java framework, all these softwares are installed on a single physical server, right? These are all based on a single physical server. Then your entire data is stored on a single physical drive, HDD, and then from that you are storing the data and accessing the data using the memory of your single physical server, memory, RAM, or CPU cores. Based on how many number of cores that you have in your server, you can run those many number of processes. Okay, so if you run more than that, its capability, so other process has to wait until the resources are released by the current running processes, right? That means which will delay in your processing. That means there is a limitation, right? There is a limitation, hardware limitation in terms of storage, physical storage. I wanted to store, I can store maybe some terabytes of the data. If I wanted to store, okay, and then petabytes of the data or exabytes of the data, there is a limitation here, right? I cannot store it, that much of data. Okay, so I wanted to process in a big way all these multiple processes that I want to run on very big data. So that means there is a hardware limitations for the single physical servers. So that means that's why, okay, because in order to meet the growing needs of the data, okay, so they have to think about an alternative, okay, alternative to deal with this in order to overcome these limitations of storage and processing. So the Hadoop is the alternative, which is implementing a distributed architecture in which we are going to use multiple machines help in order to accomplish your goals. Okay, so your data is stored in a distributed way. When you are copying the files from your Linux file system to Hadoop distributed file system, okay, the data is distributed among the cluster of machines, multiple machines. Clustering means bringing all these machines together, right? So all these machines will be connected through a LAN network, and then you are going to install the required Hadoop softwares on all these systems, so that they will be sharing the load in terms of storage and processing. So all the machines RAM is used when you are processing the data. All the machine cores are used when you are processing the data. All the machines clock speed is utilized in order to process the speed of the processing of your data. All these machines physical storage is used. Okay, physical storage is used to store the data. That's what the distributed architecture is about. Okay, so that's why you call it as a Hadoop cluster. Cluster means what? Clustering all these machines together, so that all these machines will help you in accomplishing goals of dealing with very big data. There is no limitation in the second generation of Hadoop, and there is no upper limit on the number of nodes. You keep on adding the number of nodes to the existing cluster, so that you can deal with any amount of the data in terms of storage and processing. At a nutshell, that is Hadoop is about. Okay, for dealing with that, yeah, they have provided a lot of APIs. We are going to learn about the APIs. So on top of it, you use the traditional technologies like Java knowledge, or like Scala or Python, okay, or C, C#, any of these languages that you can use to develop your logics. And then you can use your RDBMS knowledge, SQL knowledge. Okay, there are some of the ecosystems which is implementing this RDBMS concept, which works on this Hadoop framework. Okay, so you are going to use all these technologies. All these technologies, the technologies are not new. So only you use the traditional technology that you use on the a single physical servers here also. But the frame, because of this framework is kind of a distributed architecture. That's why how you have to, what are the little changes between how to use the technology in here on Hadoop framework, how you use that you are learning about those differences. And then some of the new technologies are implemented on Hadoop also. Okay, so some high level languages like your SQL language, so we need to learn those languages also apart from your regular the traditional technologies knowledge. Okay, so now before talking about Hadoop, now we are going to talk about what is big data. Okay, so based on the discussion that we have right now, if it is can I say come up with this definition? If it is the beyond the capability of a single physical server to store the data and process the data in a big way, that that data is called big data. Okay, there is a limitation. If you're talking about a single physical server, maybe they can manufacture a machine of 1 terabyte of RAM. More than that, they cannot, right? Even though if you pour millions of dollars, okay, so that is a hardware limitation. They cannot, manufacturers cannot manufacture, okay, so high configured machines so that they can handle petabytes of the data. Okay, so that's why you need multiple machines help in order to accomplish your goals of dealing with big data. Okay, so that means it is beyond the capability of a single physical server to store and process such a huge data. That data is called big data. Okay, so in the other way, okay, this definition will help you understand more and more about big data. The term for a collection of data that's so large and complex. The complex means what? The data can be categorized into three types: structured data, semi-structured data, and unstructured data. Okay, so we are going to talk about the statistics about the structured data, semi-structured data, and unstructured data. Okay, so complex data that it becomes difficult to store, okay, and process. So what are the challenges here for the single physical server? Storing in a big way, processing the data in a big way is the challenge. So using on-hand database management tools, maybe any database servers or a technologies or traditional data processing applications. Those applications might be built using .NET framework or Java framework or any other technology. Okay, so that is the limitation. All these technologies have that limitation because they are built on based on a single physical server. There are hardware limitations in order to store and process such a huge data. So now a keyword complex, right? Complex means the data can be complex. So what kind of the data can be called as a complex data? So the data can be categorized into structured data, semi-structured data, and unstructured data. Okay. In the first class, I limit the writing the things on the whiteboard or like text. Okay, so because I wanted to cover more in the first session. Okay, so that's why I'm using these slides. So subsequently, definitely when you are explaining about the architecture and all, definitely I will use the whiteboard to explain about the things. Okay, so it is kind of an overview of big data and Hadoop, right? There is not much to write on the. Okay, so big data, what is the difference? Okay, structured data. So what is the data is called what data is called the structured data? So when you talk about the data which can be loaded into databases without any issues, or you read the databases data and then generate some sequence files or like your comma separated files or tab separated files or comma separated files like that. Okay, that kind of data is structured data. It is following some data integrity rules, right? In first column integer, second column date, third column alphanumeric, fourth column boolean. So it is expecting, you are expecting the data in that way, in that manner only. That kind of data is called structured data. Sometimes you are generating the structured data. Sometimes your a lot of unstructured data is getting generated from some for example logs, system logs, or machines generate lot of logs because everything is integrated with the software, right? Like scanners and all, and obstacle scanners and all. Okay, like that they will be generating lot of log data. You have to analyze that data. That is not structured. So you have to make it structured by applying some programming languages. So if you have to clean up the data and then prepare some structured data. Okay, that way the data is getting generated from different sources in different formats, like structured format or unstructured format or multi-structured or hybrid format like semi-structured. Okay, so structured data, SQL Server, Oracle database, basically the data coming from the databases like Teradata, Kisa, and DB2, Microsoft SQL Server, MySQL and all. Okay, this is a structured data. Total data generated throughout the world, which is stored in structured format, is only 10%. Whatever all these databases that you are working, right? So they are storing only when compared to the unstructured and multi-structured. So structured is only 10% of the data that you are dealing with. All these databases, RDBMS databases. Okay, so and then the multi-structured or semi-structured is 5 to 10% only. Multi-structured means maybe XML data, your XML format or JSON format, Excel sometimes. Okay, so if you read the databases and load it in Excel, okay, that is a structured data, right? When you type in Excel sheet, it is unstructured. It won't validate the data, right? So unstructured. That's why sometimes it is called structured data and unstructured data, which is stored on Excel format. Okay, so these are the good examples of semi-structured data. Okay, Excel format, XML format, and JSON file formats. Like so, the domains, when you consider the domains, these domains might be these are the sources. Based on the sources that we categorize, means these sources might generate some semi-structured data, weather data, currency conversion data, demographic data, panel data, like this. E-commerce data sometimes semi-structured also. Most of the time it is structured, sometimes unstructured. The images and all. Okay, and when compared to the unstructured, so only 20% of the data is stored in the form of structured and semi-structured. All the other data is unstructured. Yeah, unstructured data. So social media data, your social networking data, okay, and then the data is generated from the blogs, your system audit logs, okay, and then digital data, audios, videos, pictures, geospatial data, okay, the data generated by the flights, the data generated by the signaling systems, okay, so the data generated by the signaling systems, okay, and then traffic signaling data. All this data is considered as a unstructured data, which is taking 80% of the data, 80%. Okay, so that means you need to, that is kind of a big challenge in order to store and process. It needs lot of storage space, physical storage space, as well as it needs lot of memory in order to process the data. So image processing, it takes lot of memory, right? So when we are running the other process in the single physical server, even though it is a 256 GB RAM or 512 GB RAM, and then when you are running multiple process at a time, so it is kind of a big challenge, right? You have to wait for the process. Maybe hours together your process will run to complete the processing. Okay, that's why you need to. They had to think about an alternative, and then Google thought about an alternative, and then they have created this a distributed architecture, which is called a GFS, Google File System, which is a distributed file system. They have created the concept called MapReduce concept, MapReduce, which implements a distributed, a parallel processing concept. Your data is kind of stored in multiple machines in the form of small chunks called blocks in this architecture. Okay, so that means one file data is stored in multiple machines. So based on the availability of the storage space on each of these machines, what this framework will do, it will use this machine to store whatever it can store, and then it will store some other blocks related to the data file in other machine, like that. So your one file data is stored in more than one machine, and then when you are processing the data, this distributed parallel processing concept, the MapReduce concept, will come into picture. So where they are stored, they are getting processed by using the resources of all these machines. There is a way to collect all these pre-processed output and then finally form the final processing output. That is the concept. We are going to talk about more and more in detail when we are talking about the architecture of Hadoop. What are the daemon processes which are helping in implementing in this, okay, a distributed storage, and then in implementing a distributed parallel processing concept. Okay. So that is the definition of big data. You understand, right? So one machine cannot hold that much of big data in terms of storage and processing. So you need an alternative, and then Hadoop is the alternative, which is implementing a distributed architecture. Okay. So how the big data? How big is big? Okay. So big data is similar to small data, but bigger in size. So your machines cannot hold it. Okay. So but having data bigger, it requires different process techniques, tools, and architecture. So you are limited to process only certain amount of the data. So you may not get the correct analysis if you process the data in a limited way. Okay, limited amount of the data, because there is a limitation in the hardware limitations. Okay, so that's why. So you have to use an alternative, and then Hadoop is the alternative, so that you can deal with very big data in terms of storage and processing. So if we are limited to a single physical server, you have to keep just warm data, and then archive all the historical data, and then whenever you need, just get it back and then process it and send it back. It's a lot of techniques that you need to use in the case of traditional technologies, okay, which are based on a single physical server. So there are no such limitations when you use the Hadoop architecture. That's why it is getting familiar nowadays. Okay, it is getting so familiar so that you can analyze the data in a big way, with an aim to solve new problems or old problems in a better way without having those constraints. Okay, so you use this, you need an alternative, and then Hadoop is the alternative. And then, so what are the measurements of big data? We talked about lot of data is getting generated, right? So maybe zettabytes of the data is getting generated. Okay, so from last 3 years, drastically it is growing, like exponentially it is growing. The data is going from different sources, like your security sensor data, okay, and then the data generated by different electrical equipments, okay, and the data generated by the flights, okay, and lot of other sources. Okay, so lot of other sources you can imagine. Okay, so lot of other sources. So that's why the data is in the form of different formats, like structured data and semi-structured data and unstructured data. So these are the measurements available to measure this big data, and then I have converted each of these measurements into bytes. Okay, so gigabyte 10 to the power of 9 bytes, 1 terabyte equivalent to 10 to the power of 10, exponential reading incremental by 3. Okay, petabyte next 1 into 1000. Okay, like 10 to the power of 15 bytes. Okay, exabyte 10 to the power of 18 bytes, zettabytes 10 to the power of 21 bytes. When you convert 1 zettabytes into gigabytes, it is equivalent to 1.24 trillion gigabytes. 1 zettabyte equal to 1.24 trillion gigabytes. So total data generated throughout the world up to 2010 is 1.2 zettabytes only. And then when it comes to 2014 or 15, it is you are talking about dealing with 4 to 5 zettabytes of the data. Okay, at this rate the data is growing. They are expecting to have 35 to 40 zettabytes of the data by the end of 2016. Another 4 years we are going to deal with 40 zettabytes of the data. In order to deal with, we need to do a lot of process improvements, even in Hadoop framework also. So one of the invention is Spark, which is very faster than MapReduce. This MapReduce concept, which implements a distributed parallel processing concept, is 100 to 300 times faster than your traditional technologies like Java. Whatever your Java is doing, it is doing like 100 minutes, and then your Hadoop is doing it in 1 minute. That is the ratio you can imagine. So, but Spark is which is kind of is an in-memory management system. So, which is another 50 to 100 times faster than MapReduce. You can imagine. So that because you have to create the very fast processing technologies to process this big data. So because you have to deal with 40 gigabytes of the data by the end of 2010. So you can imagine. So it is exponentially growing. Okay. So these are the measurements. Okay. So big data journey. So why you have to invent this technology, distributed architecture? So how it is growing exponentially? So in 1990 they used to store 1400 MB of the data, and per person and on average they used to store 1400 MB total data generated from different sources. If you divide it by the persons, it is 1400 MB. Then comes to 2010, it is 1 terabyte. Okay, so the storage capabilities of the people have been increased. Now we are talking about the processing speeds of the technologies have been increased or not. It is not. Okay, at a transfer speed of 4.5 MB per second, read the entire drive in 5 minutes. Then come to 2010. The storage capabilities has been increased to 1 terabyte, but the processing speeds are not up to date. Only 100 MB per second only, using the existing technologies available on the traditional systems at the time, 2010. And then using those technologies, we can process this 1 terabyte of the data, read the entire drive in 3 hours. So the customers are expecting to have very good technologies which can do the faster processing. So they expect to complete it in 5 minutes or less than 5 minutes, but it is taking 3 hours if you use the traditional technologies in 2010. So Hadoop is practical implementations of Hadoop is available from 2006 onwards. Okay, Facebook, major users, Facebook, Yahoo, okay, Google is already there because based on the white papers released by the Google, okay, after successful implementation of these technologies, okay, so this distributed architecture, so maybe they might be already implemented the technology, and then they were able to store the user clicks and then their search criteria data. Okay, so they were able to store and process the data. Okay, so by using this distributed architecture. After that, Dow Cutting, who is the father of this Hadoop, has taken this concept, okay, in 2004, and then developed in a search engine, a Google-like search engine, and then implemented this architecture on Hadoop. So after that, we are going to talk about that a little later. Okay, so by we are comparing, right, between 1990, 2010, and 2010, using traditional technologies using Hadoop. Okay, 100 drives working at the same time. That's 100 machines working at the same time. Okay, so Hadoop cluster, using Hadoop cluster, so you can process this 1 terabyte of the data in 2 minutes. So that is, it is 90 times faster than the traditional technologies. So based on how complex data that you are processing, it is 100 to 300 times faster. Now maybe 1000 times faster using Spark. In the second generations of Hadoop, latest generations of Hadoop, they developed a technology called Spark, which is having lot of modules. You can do everything in that is a kind of a big framework. Okay, so that is another 100 times faster, 50 to 100 times faster than your MapReduce concept. Okay, so how big the data grows when a clock ticks 60 seconds. How the data is getting generated. Okay, so in 60 seconds, what is happening in the world right now? In what are the sources? Like we discussed the different sources, right? So online books, online transactions, cell phone conversations data. Okay, your iPhone applications downloads and uploads. Okay, and then YouTube, how many uploads and downloads of the videos, and then playing the videos. They need to have a lot of processing capabilities to play a lot of videos by the billions of customers throughout the world. And then 70 plus domains are registered, 60 plus new blocks are created. Each block is creating large volume of the data. Okay, 168 million emails are sent per 1 minute. Okay, 694K search queries are run in different search engines like Yahoo search engine, Google search engine, or your MSN search engine. Okay, so 17 plus Firefox downloads. Like this, we can see all these sources. I'm going to share this documentation, a PDF version of this PowerPoint presentation. I'm going to share my material also I have a big book about around 250 pages, which will help you in understanding the concepts, and then it will have enough examples for you to do the practice to get knowledge about all these ecosystems. And then I am going to provide a lot of reference books also, which are validated use cases and business scenarios on each of these ecosystems, so that you can use, and then a lot of practice examples I will be sending through emails also, so that you will use all these sources to get expertise in Hadoop. Okay, so here these are all the other sources of getting the big data. Okay, so in an internet minute, in 1 minute, what is happening? 2000. What is the comparisons? How the data is growing like this? So 2013 and 2014. When you compare 2014 and 15, it is little more differences. You find a lot of differences. Okay, Facebook 461K logins, 600K logins. Instagram 38K photos shared. Now 2014 67K. Maybe 130 or 140 K photos shared in 2015, like that. Okay, Twitter 347K tweets shared, 433, like that. Google 4.1, 4.19. YouTube 167 hours of videos downloaded and 306 when compared to 2014. So the data is growing like anything. So 64,000 sales transactions. Majority in future by 2020, majority of the sales will be done through online. 80% of the sales will be done online. Those are the projections based on improving trends in buying the based on the buyers. Okay, they are using the online sales, online transactions. They are online sources in order to buy the products. So based on this, they are expecting to have 80% of the sales. All these shopping malls, kind of like you can imagine, right? So that's what happening. So that large volume of the data is getting generated from all these sources. Okay, so when the data becomes so big, so what is the challenge? What is the challenge? These are the challenges. Initially, we learned about 3 V's of the big data, right? Volume, velocity, and variety. Right? Those are the 3 V's. After that, veracity as well, 4 V's of the big data. Now, 7 V's of the big data. Okay, so 7 V's of the big data. So when the data becomes so big, it is kind of hard for the traditional systems to store and process. Best examples are Twitter. When a celebrity put a tweet on the Twitter, a lot of followers will be hitting that, right? So millions of customers. So if that servers are not capable of handling that much of data in terms of storage and processing, that server will fail. Okay, you can take an example of IRCTC few months before. At the Tatkal time, right, 10:30, if you wanted to do the Tatkal reservation, what happens? So your servers are down. That's why you are not successful in completing the reservation, right? You have to wait half an hour or 45 minutes because everybody is sitting. Now they improve the scalability of the servers. Now you are able to do it. So that is the best example of these things. Volume. When the volume in terms of storage and processing increase, so your systems may not able to store and process such a huge data. Velocity. So Twitter and IRCTs are the best examples for this. Okay, so the velocity, okay, the rate at which the data flows, the faster rate. So your systems are not able to process that much of big data. And then variety of the data, like structured data, semi-structured data, and unstructured data. It varies based on what kind of the data that you are processing. So unstructured data will take a lot of memory and storage space in order to store and process the data. And then large volume of the data is in that format. And then the veracity of the data. The value of the veracity of the data means like accuracy of the data is kind of a big challenge when you are dealing with very, very big data. Okay, veracity. And then value, taking the value out of that big data is kind of also a challenge. Variability of the data or vulnerability of the data. So it is kind of the patterns keep changing. The pattern particular, you are expecting a pattern of the data that is coming, that is keep changing in a regular intervals. So that so you cannot imagine what is happening. So if you use the traditional systems, and then your system hardware is a kind of a big challenge, and then another thing you have to think about the other alternative, how to do that. These are all the challenges, and then the visualization in the front end tools, how to visualize the data when you wanted to show the data on some BI tools or like your front end tools. That is also a big challenge. So now 3 years, 4 years, and 7 years based on increasing volume of the data, and they find out all these challenges and keep on adding these challenges of big data. So that's why 7 B's of the big data. Okay, so big data analytics. What do you get out of this big data analytics? Why companies are aggressively, your financial institutions, your social networking websites, okay, and online transactions. What purposes they are doing? What purposes they are using this Hadoop technology for doing the analytics? Okay, so what is the role of these analytics when the data becomes so big? Examining large amount of the data, this kind of analytics, comes in the analytics. Yeah, finding out of very big data, find out the appropriate information. You wanted to take certain data only out of that big data for doing a certain type of analytics. Then other people might use the other type of patterns for other analysis, like that. Okay, finding out appropriate information out of this very big data. This kind of comes under analytics. Identification of hidden patterns and unknown correlations. Okay, and then competitive advantage. Okay, when you do the analytics on a big data, you can come up with a good business decisions so that your business will be improved. That way, you make a difference between the other competitors in the market. Better business decisions, both strategic and operational. Okay, effective marketing, customer satisfaction, and increased revenues are the outcomes. Okay, so applications of big data. So it is not limited to a specific domain. It can be used for all the domains, like your retail industry, okay, and social networking, and then e-commerce applications, okay, security surveillance data, and security sensor data, okay, and then cell phone conversations data, different domains. All these domains data can be processed using this big data frameworks. Okay, so when you take a case study on healthcare, so 80% of the medical data is unstructured and is clinically relevant. Data resides in multiple places like individual AMRs, lab, imaging systems, physician notes, medical correspondent, and claims. Okay, so when you analyze this data, which is gathered by different sources like this, okay, you put it in one system, analyze all this data, okay, and then you can come up with a very good decisions to maybe diagnosis or prescribing a correct medicines to the patients. Okay, so means if you use this data, all this data which is generated from different sources like this, you can replace an experienced or an experienced doctor also. So because you are analyzing years together data, different patients data, different kind of data. Okay, and so that you can come up with a good decisions. Okay, leveraging big data. What are the outcomes? Build sustainable healthcare systems, collaborate to improve care and outcomes, and then increase access to healthcare. These are the outcomes of applying this big data analytics on healthcare data. Like that, you can imagine maybe financial data. A lot of things that you can use this in the financial industry. Like you can do the risk analysis on the data, fraud analysis on the data, and then recommendations. You can do the recommendations. Okay, using some machine learning algorithms on very big data, on years to the data, and then give the suggestions to the customers. Okay, so that is about the big data. Any questions on big data? Now we are going to talk about some little technical part of it. Hadoop. Again, this first session is kind of giving you an overview about the big data and Hadoop. Not too much technical. Okay, and advantages and all. the prerequisites. Any questions before starting about Hadoop?
Hi Veer.
Yes.
Yeah. So do you mean that big data is an abstract form and Hadoop is a more technical and realistic one?
The big data is kind of a data, right? A large volume of the data, which cannot be held by single physical servers. If it is small in size, you can use your Java technologies or .NET frameworks in order to process it. When the data becomes so big, so you need to take the multiple machines help. Machine help means it is kind of a framework on which you are using multiple technologies to store the data and process the data. For that, you are learning this. So that's why it is technical. So big data means kind of a keyword, right? Which is kind of describing very large volume of the data. Big data. It's not a technology, right? Big data. Hadoop is the technology framework in which you are going to use your knowledge to process the data or store the data. Big data is kind of a term which is used for describing very huge or massive amount of the data. It is not a technology. That is the difference.
Okay, so you mean that
Hadoop means you are going technical, right? So Hadoop means you are learning about each of these ecosystems.
Yeah, so you mean that similar to Hadoop, you can have several other technical tools which can deal in with big data.
Yes. Which can deal with big data to accomplish your goals. So in a big way. So multiple users can run their processes at a time. Multiple applications can access the resources of all these machines at a time. And then all these multiple applications can store their data on this a big data framework. Okay, a big data physical storage, so that you can use all multiple machines help in order to store your data. Even though petabytes of maybe 4 terabytes of the file can be stored.
Yeah, thanks.
Okay, without any limitation here. Okay, so Hadoop overview. An open source software framework. So what is Hadoop? Okay, we just talked about a little bit about initially, right? About what is Hadoop. Okay, an open source software framework which is used for majorly for storing the data and processing the data in a big way. Okay, so by here an open source. What do you mean by an open source? We won't charge for that. So even though they are providing some enterprise editions on which they charge something, which is you are getting a lot of additional features on the enterprise editions. But every distribution, nobody uses Apache, which is in a completely open source, right? Completely open source. Lot of distributions are available in the market, like Cloudera distribution, Hortonworks distribution, Mapr distribution, IBM Big Insights, OI, they have their own product, and then Greenplum. Okay, like a lot of distributions are available, commercial distributions are available in the market. Even though they are available, they charge for enterprise edition. They have to provide compulsory one open source product, because all these major distributions have taken this softwares, open source softwares from open source Apache, which is kind of a non-profit organization. Open source, it is an open source foundation. Okay, so it is funded by a lot of commuters and committers. Okay, so that they will provide everything for free, software for free, and then source code also they are providing. If you go to the Apache website, you can see the links for downloading the software as well as source code also, so that you can, to suit your requirements, you can modify the code if you are comfortable in modifying the code. Okay, so that way all these distributions come into picture. They are doing the R&D from that point onwards. So all these IBM and Cloudera, on their R&D labs, they are creating new products like Impala, which is a product of Cloudera. Okay, like different distributions. So maybe Mapr, they are having their own a file system called Mapr file system. They are not using HDFS file system. Mapr file system, more like faster retrieval. Okay, so it is developed using C and C#. But Hadoop is written in Java. Completely all these Hadoop framework. all these ecosystems are written in Java. Hadoop, Hive, Big, all these ecosystems are written in Java. And then Mapr. So they have taken the open source. They are developing their own products so that you will get the open source code as well as the software. Okay, so an open source software framework, it is a framework. Framework, you know what is a framework, right? It is kind of a skeleton it is providing. A framework means it is providing some APIs. By using those APIs, by overriding those APIs, you are going to develop your code. Okay, so that using that APIs, you are developing further and then accomplishing your goals. So that's what framework is about. Okay, it is having a skeleton, so that on that skeleton you are using your knowledge to implement your business logic. That's what framework is about. Okay, so which is used for what? What are the major challenges on the single physical servers? Storing the data in a big way, processing the data in a big way. For that storing and processing, you are using this Hadoop framework. Processing data sets on clusters of commodity hardware. Clustering of machines. Clusters means what? Bringing all these machines together, connecting all these machines in a LAN network. And then using the commodity hardware. You don't need to buy the expensive hardware like Teradata, very pretty expensive. Even though it is giving you a distributed architecture, it is limited to handling only structured data only. Teradata is a kind of a database. If you wanted to deal with structured, unstructured data and semi-structured data, it does not cater your needs, right? So you have to have another framework, okay, which can deal with all types of the data. Okay, so but Teradata is pretty expensive. Even though large volume of structured data can be stored and processed there, it is pretty expensive. Then how expensive it is? You can use Hive, which can replace the Teradata to build a warehouse, which is like 90 to 99 times less cost. Okay, so 1% of the cost of the Teradata. If you give it to this Hadoop, you can implement the same things what you can do by that the other technologies like Oracle technologies, and then any other technologies like HP's Vertica is also a distributed architecture, but pretty expensive. Okay, because their software will work on that hardware only. That's a lot of cost savings because of the commodity hardware. So here you are using a commodity hardware, not expensive hardware. You can use the assembled machines for building your cluster nodes. Okay, so there are some master nodes and how to come up with the design of the master node hardware and then slave nodes hardware. So we are going to talk about when we talk about the Hadoop administration. Okay, server hardwares. Okay, so commodity hardware means cheaper hardware. Any assembled machines can be used to use as one of the data nodes. So all these machines, each machine is called a data node here in the Hadoop architecture. Okay, master machine is called the name node, and then all the slave machines are called the data nodes. Okay, it is kind of a master slave architecture Hadoop. When you are having multiple machines, out of these 100 machines, 1000 machines, or like thousands of machines. Okay, so one machine is acting as a master. All these machines will be acting as a slaves. So in terms of processing, that's basically a master processing is running on one machine, which is the managing all these slaves. Master slave architecture. It is kind of a master slave architecture. So tomorrow we are going to talk about that. Okay, Hadoop architecture. So then we are going to talk about that different process, daemon processes, which are making which are helping you in implementing this distributed storage and distributed parallel processing concept. That's what Hadoop is. It is an open source software framework which is mainly used for storing the data and then processing the data in a big way using the cluster of machines help, cluster of commodity hardware, clusters of commodity hardware. That is what Hadoop is. Okay, so history of Hadoop. So Google publishes Google File System and MapReduce framework papers in 2004, and then by taking this concept by Dow Cutting and his small team called Mike Caprella and then Tom White who has written this Hadoop Definitive Guide version 4. Okay, so Dow Cutting and Nuts team implemented Google's framework in Nudge search engine. After successful implementation, Yahoo hired Dow Cutting and his team to implement Yahoo groups into Hadoop. After successful completion of that project at Yahoo, they have think about contributing this software to open source Apache. In 2008, they have contributed the software to open source Apache. From that point onwards, the Hadoop, it became a hot technology and on Apache framework. So Hadoop became Apache top level project from 2008 onwards, because everybody started using this Hadoop because it is cheaper, cost efficient. Lot of other advantages that we are going to talk about this because of this Hadoop architecture. What are the advantages that you got apart from just cost savings? Because you are using committed hardware, that's a lot of cost savings. Because you are using open source software, so even though enterprise editions are very cheaper when compared to the other softwares like Oracle software or Teradata software, like any other tools. So there are a lot of, this is the typical Hadoop cluster. We are going to talk about more detailed technical part of it in our next class. So when you send the request from your client machines, client machines, either storage request or processing request. Copy the files from my Linux file system to Hadoop distributed file system, so that it is spread among the cluster of machines in terms of small things called blocks. That means one file data is stored in multiple machines. That kind of request that you send from your server, from your client. And then these are all the master nodes. These are all the slave nodes. Multiple slaves will be there. One master will be there. Related to storage, one master will be there. Related to processing, one master processing master process will be there. And then multiple slave processing will be there. In each of these machines, a process which is related to storing the data in the form of small things called blocks. And then like that, you will have these data nodes process are running in multiple systems, so which will take care of the storing the files in a distributed way. One master will be there, multiple slaves will be there. This is a typical Hadoop cluster. We are going to talk about it in our next class. Now we are going to talk about why everybody is choosing Hadoop for their big data needs. What is the advantage? Scalability. So it is scalable enough to take any amount of the data in terms of storage and processing, because Hadoop is using multiple machines helper. So it is using the resources of all these machines in terms of storage and processing. That's why it is accomplishing your goals of storing very, very big data and processing very, very big data. Available. It is available all the time. All the time. So availability is more. Why? Because it has a failover mechanism. So because your data is stored in multiple machines, you put some backup machines. So some additional data nodes available, to take up the failures of the existing machines. That's right. So by default, when you are copying your files into Hadoop distributed file system, from local file system, which is Linux file system, so it is sending the data into multiple machines. In the same time, it is keeping multiple replications based on how many copies that you want for each file. It will, by default, it keeps 3 copies. So however, whatever the data that you wanted to store, your production systems are generating, you have to do the backup copies, right? If something happens to the server, you have to restore the data, right? A standby machines needs to be here. So that's why, however, you are having 2 copies there. But here in Hadoop, by default, they kept 3 copies. Anytime 2 copies gone, and then you have another 3rd copy, which is the default. But you don't, you cannot afford keeping 3 copies for all the files. You have a facility to keep only 2 copies for some files. So when you are copying the data, and then you can mention that I want only 2 copies for this file. So it will keep only 2 copies for that particular specification. By default, it keeps 3 copies. 1 copy dies, automatically you will have another 2 copies available. So your storage is not lost, and then your processing never stops. So that's why the availability is more in this Hadoop framework. So in the second generation of Hadoop, so they are providing 100% availability by providing the cluster mirroring also. So it is dealing with the disasters also. Okay, so if your entire cluster is gone, if one data node is there, whatever the data which is stored on that dead machine will be taken over by the other available live machine, so that it is taking care of your continuation of storage and processing without any disruption there. But your entire 1000 node cluster is in your storage room here. This is washed away by a cyclone or something like that. Okay, floods or something like that. Then what is the alternative? It is the latest versions of Hadoop distributions. They are providing cluster mirroring. Same data is in another geographical locations. So within hours you can turn on that cluster so that your cluster, your data is not. So that's why almost 99.99% availability it is provided, Hadoop cluster. Okay, when compared to the traditional systems, the availability is more, reliability is more. So whatever the reliability that you are getting from the traditional systems, you are getting all that reliability in from Hadoop. And then cost effective. Why? Because you are using open source software, and then okay, you are using open source software and then a commodity hardware for building the Hadoop architecture. Okay, so it is flexible. It can deal with, for example, Vertica. Okay, it can deal with 200 terabytes of the data or 300 terabytes of data because it is using distributed architecture with Vertica, HP's Vertica or Teradata. So, but they are dealing only databases, only structured data, only 10% of the data. What about the other 90% of the data? So, compulsory you have to come to Hadoop architecture in order to reach your goals. Okay, of dealing with structured data, unstructured data, and semi-structured data. So that's why it is cost effective because you are using commodity hardware and then you are using open source software. It is flexible. Flexible means it can deal with structured data, semi-structured data, and unstructured. It has lot of components available on Hadoop framework to deal with any type of the data. Okay, and then faster. Why it is faster? Because the data is stored in the form of small things called blocks, where they are stored in multiple machines. They are all these blocks parallelly processed by this framework. Okay, so the software component, the APIs provided the framework will help in implementing this distributed parallel processing. That means one file data is kind of like 1 terabyte of the file that is copied from local file system to Hadoop distributed file system. It is divided into maybe 8,500 blocks. That means all these 8,500 blocks are stored in 10 machines. So by using the resources of these 10 machines, okay, so all these blocks will be processed simultaneously. Definitely, instead of processing 1 terabyte of the data at a time, which happens in the traditional systems, okay, in Hadoop, you are processing only 128 MB data or 64 MB data or 256 MB data based on the block size that you defined at the time of installing your Hadoop cluster. What configuration that you configured. Well, the default block size 64 MB or 128, 256 or 2 GB, whatever. Based on that, it will divide the data into those many number of blocks, and then only each block is by default fed into this MapReduce concept. So, and then it will process that block at a time. So, because you are processing here a small amount of the data, but you are implementing a distributed parallel processing concept here by using the resources of all these machines simultaneously, and then you are getting benefit. That's why you are faster. Okay, you are at a time. In the traditional system, 1 terabyte at a time. Here, only 64 MB. Definitely, to process 64 MB, it is faster. So that's why you are faster here. That's why. So it is faster here. Okay. So that's why it is faster. Resilient to failure. Any machine in the network can fail. Whatever the data which is stored on that machine or which is getting processed on that machine will be taken over by the other available live machines, because multiple machines are running simultaneously. All these servers are up and running, and then on all these servers your Hadoop softwares are up and running, which will take care of. Okay, so the data which is stored on the failed machine or the data which is getting processed on the failed machines. So that's why these are all, because of all these advantages, companies are aggressively moving towards using Hadoop. for their big data needs. Clear about the advantages? Why companies are? Okay, because we are talking about the statistics, how much billions of dollars will be spent in future. Why you have to you have to choose Hadoop for your career. Okay, so what are the pay ranges for Hadoop? Okay, and when compared to the other technologies. Key breakthroughs of Hadoop. Okay, from Mapr. Mapr, one of the major distributions of Hadoop. They have provided this. Why you have to choose Hadoop? Okay, for dealing with your data to do the analytics. Overcomes the traditional limitations of storage and computing. Okay, so there is no limitations on storage and computing. Okay, in the here because multiple machines. And then leverage inexpensive commodity hardware as a platform. Inexpensive hardware. When assembled machines can be used to build one data node like that. Either master hardware or slave hardware. You can use the commodity hardware, which is available in the open market. Provides linear scalability from 1 to 4,000 servers. It is in first generation of Hadoop. There is no upper limit in the number of nodes in the second generation of Hadoop, where high availability and then HDFS federation are implemented. Okay, so that means when you are getting more and more data, you keep on adding one more data node, one more data node, one more data node to the existing cluster to take up the new loads. And then low cost open source software, low cost. So even though commercial distributions, they provide the enterprise editions, when compared to your worker licenses or federated licenses, it is pretty cheap. Okay. These are the advantages of Hadoop, and then based on these advantages, how the companies are getting these advantages by using this Hadoop. In industry sectors using Hadoop, search engines, okay, search engines are using this Hadoop. Okay, social networking sites. Practical implementations of the Hadoop is done in Facebook in 2006 onwards. They used Hive in 2006. Okay, so okay, so Yahoo used created Pig. So they have developed that Pig software. Okay, they used the Pig in 2006 and 2007, early 2007. Okay, like that. Okay, so the social networking sites, finance and banking. Okay, so like American Express, Amol is working in American Express, right? So they are using Mapr cluster, Hadoop cluster for big data analytics. Okay, they have their own architecture to how to bring the data, what are the intermediate places they are storing the data, and then how they are finally putting the data into Hadoop cluster like that. So based on their domains, okay, based on their requirements, they are using some third-party tools also for implementing, which are integrated with this Hadoop framework. Okay, financial banking, so Bank of America, okay, they are into Hadoop. Wells Fargo, they are into Hadoop, and Chase, they are into Hadoop. Everybody who are wanted to deal with this big data to do the analytics in a big way, they are using this Hadoop. Retail industries like Walmart is in Hadoop, Target is in Hadoop, Best Buy is in Hadoop. Okay, for recommendations for the products when they are buying the products online. E-commerce like Amazon and eBay and then Flipkart, all are using this Hadoop architecture for dealing with their data in terms of storage and processing. Okay, e-commerce, they are using this Hadoop ML libraries, machine learning libraries for giving the recommendations to the users. When you buy a product, it will be giving you associated products also, right? How they are giving based on the user patterns, your kind, you are selecting this hard, so you might buy the other associated products like this. How they are doing? So they are using this ML libraries in order to give you the recommendations. Okay, and then email services, compulsory in order to store all these 168 million emails are sent per 1 minute, right? Maybe like per day, per year, you can see, right? That much of big data in order to store and process it. Compulsory, all these email servers are using this Hadoop. And then security sensor industry, and then government and public sector. Okay, American federal government data is migrated into Hadoop in early 2016. Okay, and then Indian Aadhaar data is into Hadoop now. Okay, Aadhaar data, they are storing our citizens' data in Hadoop clusters. So it is not specific to a particular domain. Any domain that you can use. If you can use the traditional technology, you can use Hadoop platform for dealing with your requirements. Okay, industry sector, major clients who are using this Hadoop: Amazon, Twitter, IBM, Adobe, Facebook, LinkedIn, Yahoo, all these clients. So that you don't need to worry about using this technology for dealing with big data. Okay, the future of Hadoop. The future of Hadoop. So what is the future? What you get out of it if you learn this Hadoop? What are the companies or how the companies are getting benefited out of using this? Okay, 33% of the companies are using it right now. Another 20% of the companies have started their development in Hadoop. Okay, so and then 58% compound annual growth rate (CAGR) usage of Hadoop is increasing year by year. Okay, by 2020, and $222 billion will be spent on Hadoop. Okay, so that means you can see how many number of jobs are getting created on Hadoop to doing the big data analytics. Okay, so and then compared to the other technologies, so at what rate Hadoop usage is this? So that means these are the jobs getting created in future. Okay, so cloud computing, and then in Hadoop can be built on AWS also if you want. Okay, AWS has its own product called MapReduce. Okay, they have their the MapReduce, Hive, Scoop, all these ecosystems, they have their own product. Okay, which is called Elastic MapReduce. Okay, they have their own products. We can use their project, or you can build your clusters using their Elastic Compute Cloud EC2 or Simple Storage Service S3, Amazon's S3 to build your Hadoop clusters. So you can reduce further cost. You can reduce your cost if you use the cloud in order to build your Hadoop cluster. So in Hadoop, Hadoop can be built in your cloud also. So it is up to 2012. Okay, if you see the statistics from 2012 to 2015 or 16, it is growing drastically. It is nearer to this graph. Okay, so those many number of jobs are getting created in Hadoop also. Okay, and then Java persistent API, it is going consistently, and then enterprise Java bunch, right, going consistently. And then there is a big drastic change in creating the jobs in Hadoop side. When you type it in Google, highly paid jobs, technologies. So you see out of 20, you'll see 10 to 12 technologies, Hadoop related technologies, which are the technologies which are integrating with the Hadoop. So those are highly paid jobs right now. Okay, so that is the reason why companies are also aggressively moving towards using this Hadoop for their big data needs, and then that's why a lot of jobs are getting this. And then this is having a place for if you learn Hadoop, these are the okay. So for example, what are the roles that you can get into? So okay, Hadoop developer. If you have some programming knowledge, okay, some programming knowledge, any languages like C, for writing the MapReduce programs, you can use C, C#, Java, Python, Ruby, R language, PHP, Perl. All these languages can be used to write your MapReduce algorithms. Okay, so any of these languages. Spark has using another language called Scala also. Okay, so right now in Spark you can use Scala, Python, Java, and R languages. Okay, so like that you can use if you have any programming knowledge, you can put into as a Hadoop developer. And then data warehouse developer. So they have Hadoop So okay, so data warehouse developer. If you have some data warehouse knowledge and then some SQL knowledge, okay, any databases like Oracle knowledge or like MySQL, Microsoft SQL Server or MySQL or PostgreSQL, any of these databases that you work, so you can use that knowledge on the Hadoop framework, because Hadoop has different ecosystems like Hive, Impala, Apache Drill, which implements RDBMS concept. Okay, so that knowledge is used here. Okay, so you can get into as a data warehouse developer, and then Hadoop has some NoSQL systems. Okay, NoSQL systems, which is different. We are going to talk about the NoSQL systems in our next class. Okay, I'm going to finish it in just 5 minutes, because just the theory part we complete. Tomorrow we are going to talk about all the Hadoop course curriculum components. So what they will do, what are the underlying technologies. Okay, so we are going to talk about data warehouse developer, and you have HBase developer, HBase developer, HBase developer, HBase like HBase, MongoDB, Cassandra, MarkLogic. All these are the open source products available in the market. They are the good competitors in implementing NoSQL concepts. It is also a database, but a NoSQL opposite to your RDBMS. How the RDBMS store the data? So it stores the data in it in the form of database and tables, right? Here we use NoSQL also. It is storing the data in terms of that in data as a database. In the form of tables. But that means columns and rows, but it works in a different way, non-RDBMS. Okay, HBase, MongoDB, Cassandra, and MarkLogic are the competitors in the market in the HBase. So we can get into as a HBase developer, and then Hadoop tester. If you have some testing background before, we can get into Hadoop in testing. Hadoop has a testing framework. If you write the MapReduce code, they have provided some framework to test your MapReduce program, and then so a lot of third-party tools are available also in the market, okay, which are integrated with this Hadoop framework, so that they test you can test your SQL implemented systems data, and then your they have them MR unit. It is having MR unit, which is used to which is kind of a testing framework, which is used to test your MapReduce programs. And then they are using some third-party tools also to test your all Hadoop components. Okay, you can test your applications which are built using other components of the Hadoop framework, Hadoop tester, and then you can get into Hadoop administrator if you have some a good system administration knowledge or your Linux knowledge. If you are a Linux administrator, you can get into Hadoop administration, Hadoop administrators. Okay, Hadoop administrator. So these are the roles that you can get into. So these are the roles that are in the traditional technologies. Here also you have the players. Any of these, it's kind of a ocean. Hadoop is framework is kind of a ocean. Okay, so it has its own technologies also, like Pig Latin language that you are going to learn when you are using Pig. Okay, so like this, so you can use these different technology. You can get into all these roles. So if you learn this Hadoop. Okay, so these are all the when you talk about the Hadoop framework technologies, what technology is creating more and more jobs also. So I'm going to share this documentation so that you can just give take a look at these trends. Okay, so this is the course we are going to talk about. It will take a lot of time to talk about it because people will be going to work, right? 9 o'clock. That's why I will leave you. Okay, so then we are going to course deliver from this course. Okay, I have written a book, a handbook, which is more practical, which is explaining about all these ecosystems. Spark, all the I have the book, and then Hadoop administration. I have written another 200 pages of book. Hadoop development. So all these components like HDFS, MapReduce, Hive, Pig, HBase, Bloom. Okay. So and then Impala, all these technologies. For all these technologies, I have provided enough knowledge, enough the theory for it, the required theory for it, and then some practical examples, and how to do that, and then how to install it if it's a specific component. So that material is that I am providing. Along with that, I am giving you a lot of reference books, use cases, case studies, and then through emails regularly I will sending a lot of practice exercises, so that I will show you some examples. It is going to be more practical. So 50% theory and 50% practical. I will be showing whatever I am explaining. I will show you all these features by showing you, so that I will be providing the recordings also, so that one more time you can have a recording. You can turn on that recording again and do the practice, because it is a new technology. So a lot of new terminology in coming to pictures. You have to make some revisions initially. Okay, and then so a lot of practice exercises for each practice. It is kind of interactive. You can stop me. Mostly like you will have 10 people or 10 people finally. Okay, so who will be involved in this class, so that it is going to be more interactive. You can stop anytime, and then every first 10 minutes will be allocated for clarifying the questions from your practice. After going home, you will be doing some practice where you will get such somewhere, and then we will be addressing all those issues. And then if you have any conceptions, clarity, conceptual clarity on some of the topics, we will do the 10 minutes. And then before leaving the class, it is going to be 1.5 hours. 10 minutes before the class, after that 10 minutes after the class, we will be allocating for clarifying your questions. Okay, so that's why it is more interactive. And then techniques for certification exams. Okay, so I will be providing the certification guidance and all. Okay, regularly we will conducting some examinations, so that you will get the clarity on the topics. So that based on the you evaluate yourself. It is kind of an online class. You evaluate yourself. After sending this question papers, I will be sending the key after this. So that you can evaluate where you stand, so that you can go ahead and go into deeper on each of these topics. Okay. Finally, we will be providing a lot of questions from the cloud certification exams, so that how if you get certified, I would suggest you to go for a certification, so that you should be able to deliver the projects if you can clear one certification exam. So they will be giving you a lot of case studies, scenarios, which is usually in your regular work you will be doing those scenarios. So with your experience, you should be able to write that examination by spending some more additional time over your weekend, and then sometimes some of your time in the evenings. US people maybe in the mornings. So to do the practice and then get clarity on the concepts by referring some reference documentation. Okay, so these are the course deliverables that I am going to provide, and then course curriculum, and then the Hadoop architecture we are going to talk about in tomorrow's class. Hadoop architecture. Okay, so any questions before leaving the class? Any questions?
Hi, this is Naresh.
Naresh,
So,
yeah,
Naresh. Yeah, actually, I am the administrator. So, how can I learn this development part? Because I don't know Java, and even I don't know that SQL.
Oh, okay, but we are going to talk about lot of configurations on all these systems. There's some installation part of each of these systems, and then even though you are not from the development background, say Linux administration, you need to know what the developers are doing, because some of the performance issues will be resolved by the administrators, and then some of the things coding side they do that as a developer. So that's why. So you need to know the things what the developer is doing. Okay, so we will be talking about lot of performance improvement techniques on each of these ecosystems. So you get an overview of the things, even though on a regular basis you are not doing the coding, you are not developing the MapReduce programs, you are not writing the SQL scripts, DDL scripts or DML scripts. Okay, so you are not doing that in a regular basis, but so you need to learn what they are doing. For that, it is better to learn these development concepts. It is kind of mix of the things. So even though they are doing the development, they will get 30 to 40% of the administration part also in this development.
Okay, that means I may need to learn this Java, basic Java.
No, you don't need to learn that, but it is a framework, right? You need to learn about the flow, end-to-end flow, how it is doing that, in which stages it is doing that, where the administrator come into picture is to improve the performance, where the developer come into picture in order to improve the performance. So for that, So it is kind of a combination of the things.
Okay, fine.
Okay, so that's why I suggested you to get into this, and then parallelly over the weekends you can come over here. We will talk about a little more about the advanced. Parallelly, we'll be working on one development and administrations. Who are looking into the administration first, I will be conducting a separate classes separately over the weekends. Nikhil and then his friends and you, Naresh, and then some other people are there who are into this Hadoop administration. Parallelly, we'll go with the development.
Okay,
Okay, even the developer curriculum that I sent, so we'll be covering some administration also. How to set up a multi-node cluster. Okay, what are the basic Hadoop management tasks, that, how to manage the Hadoop cluster. These are the things that we discuss for the developers. Okay, it is kind of a full-time, full course curriculum, 60 hours. So we'll get complete picture about all the ecosystems, so that we can explore more and more on these ecosystems by using this knowledge that you gain from these sessions. Okay, so you can disturb me anytime. Okay, because when I am in a corporate session, I won't get the call. Okay, definitely I will return the calls.
okay.
Okay, anything else? Okay, same time we'll be meeting 7:30. Please try to be there by 7:30 so that we will get advantage of having 1.5 hour session, so that we can answer your questions and then get enough subject for you to prepare after completion of this class. So it is Monday to Friday. So Saturday and Sunday I will leave it for your practice, because we'll be keep on going, right? So you have to do a lot from your side also. So that's why. So I'll give off on Saturday and Sundays. Okay. So 1.5 hour Monday to Friday, 7:30 to 9. So everybody is good about this timing, or like 15 minutes here and there that we can adjust based on your this confirmations. Okay. You tell me your available. Okay. So thank you so much, guys. We'll meet 7:30 tomorrow.
Thank you.
Okay. Thank you, guys.
Thank you.
I'm going to share this recording also.